precision. After a space voyage that lasted almost 10 years, Rosetta finally viewed its target up close. Using its maneuvering engines, Rosetta entered into orbit around the comet and started surveying its surface, collecting all sorts of valuable data. The comet's unusual shape, with two lobes connected by a neck, was the first thing noted by astronomers back on Earth. To Rosetta's stream of data, astronomers calculated that both lobes have a volume of more than 20 cubic kilometers and a mass greater than 10 billion tons. High-resolution photos and other data constantly beamed by Rosetta back on Earth allowed scientists to choose the most suitable spot for landing. The complicated maneuver started on November 12, 2014, when Philae detached from the mothership and began its controlled descent towards the comet. Unfortunately, the landing was not smooth. The landing module bounced twice and landed in an area that prevented sunlight from recharging its batteries. Thankfully, Philae managed to send its data before its batteries ran out. Among the various chemical compounds discovered in the comet, scientists also detected water. Its chemical signature, however, is different from that of Earth's. At first glance, this discovery seems to support the view that asteroids, rather than comets, were after all more important in supplying our planet with water. To be honest, though, it is still too early to draw definite conclusions. Furthermore, among the many organic compounds found on the comet was the amino acid glycine, a key ingredient not only of DNA, but of the cellular membrane as well. This discovery seems to support the view that comets brought to our planet complex organic compounds that were crucial to the emergence of life. Again, however, it is still too early to draw definite conclusions. Rosetta's historic mission ended on September 30, 2016, with its controlled impact and destruction on the very comet it had been investigating for more than 2 years. The scientific analysis of all the data, however, will continue for many more years to come. The distant realm of the Kuiper Belt is much more than just the reservoir of small period comets. Take, for example, Pluto. Considered to be the 9th planet of our solar system, Pluto was demoted to the dwarf planet status in 2006, after the discovery in the Kuiper Belt of other objects similar to Pluto. So far, the only spacecraft to have visited the Kuiper Belt was NASA's New Horizons, launched in 2006. Nearly 10 years later, on the 14th of June 2015, New Horizons approached Pluto, revealing for the first time the planet's true face. Images and other data collected by New Horizons increased significantly our knowledge of this frozen world. Pluto's surface is covered with water, nitrogen, and methane ices, occasionally colored red by interaction with solar ultraviolet light. Steep and jugged ice mountains rise 3 kilometers above its surface. And these formations, extending for more than 150 kilometers, may be ice volcanoes, the largest discovered in the outer solar system. Pluto's most striking feature may be its icy, heart-shaped plains. Recently, astronomers analyzing New Horizons data announced that beneath its icy heart, Pluto may hide an underground ocean of nearly frozen water. Diameter almost half that of Pluto, Charon is truly a giant moon compared to its dwarf planet. The general features of Pluto and Charon indicate that these frozen worlds may have been formed because of a massive collision. The human spirit of exploration remains as potent as ever and continues to inspire as we explore the furthest reaches of our solar system. And who knows, someday it may even guide us beyond its bounds. In the beginning of the 20th century, when Konstantin Tsiolkovsky, the founding father of theoretical astronautics, dreamed of rocket propulsion, artificial satellites, and space stations, he would never have thought that these revolutionary ideas at the time would become reality in just 50 years. Asteroid mining is perhaps his only prediction that has not yet come true. Nevertheless, astronomers have already begun to investigate the means to implement such a daring mission. We do know that asteroids contain considerable amounts of valuable and rare metals.